gentlemen.
This is the 431 class of 1986. You know, the 431 is getting ready to go to St. Louis next week, I think it is. Or is it this week?
Next week.
Next week. This was the trip to Highland, Illinois that we went on in '86. And anybody know who this is?
Elich.
It's going to be on the final exam, guys, so
Close. She has 2 sons here in school. That's Marisa Crow from Missouri. That's a P. Anybody who know who this is? That's Bernie Lesieur. He was my student, and he's now a professor at the University of Wisconsin.
when he's there.
When he's there. Anybody know who this is? That's this guy. Hisham Othman. He holds, I think, the indoor record for completing his PhD in, I think it was less than 2 years.
Wow.
He came here from Michigan with a master's. Marisa was from Michigan too, only it was her master's. Hisham was a student of Pi's, and this was when Pi was into all of his energy function things, and you can tell us about your thesis sometime, but you have other things to talk about maybe today. But Hisham went from Illinois with his PhD to GE in Schenectady, New York, which was the leader for power system analysis, dynamics, almost everything. Then you went to ABB, Sia Brown Boveri. Sia is the Swedes, right? Brown Boveri is the Swiss. Put them together, you get Westinghouse.
No. ABB?
Didn't they buy out Westinghouse?
Yeah, they bought out some part of Westinghouse business only. CBS bought Westinghouse also.
Okay, yeah. But anyway, Hisham worked for ABB and was head of a Middle East unit, Near East unit. And then he went back to Jordan and formed his own company for a while, and recently got into solar renewables. So he is now working, and I forget the name of your new company.
Sun Edison.
Sun Edison. So let's welcome Hisham Othman. Kevin, do we use this or do we use
I'll take this.
a mic? Okay.
Yeah, you notice how Professor Sauer mentioned professor at university, and then me. So I'm really glad to be here today after over 25 years since I left this facility, not this facility actually, the previous facility. But I haven't been to town for about 25 years. And it's really nice to be back here and to look around. Didn't recognize half the town. And I recognized where the old electrical engineering building is. So it's nice to be among friends, I hope, and colleagues. Now, today I'd like to talk with you about certain things that through my career I've seen and really transformed the way, had an impact on the way of my work and what I have become so far. And it's really things that are happening to the industry, that happened to the industry already, our system industry, and things that are just about happening now. So I'd like to kind of cross that where things, when I graduated here, power system was not in the highest, desirable career to be graduating with. But today, I would say it's probably the most exciting field anybody can actually be, and I'm quite thrilled to be in power systems these days. and I'll tell you why. Now, when I graduated from University of Illinois back in '87, somewhere between the old grid where Edison started in New York City and the smart grid where we're all working on and researching and trying to make it happen. So let's take a look at the power system grid. Some argue it's the largest machine, largest industrial machine on Earth as the power system. So it's a massive infrastructure. In the United States, this massive industry is serving all of us, serving 150 million customers. Of course, that's meters. And in doing so, it's serving all 300 million of us. It's connecting 7,000 power plants. It's doing it through 5 million miles of transmission and distribution lines. And it's doing it through business entities, utilities, co-ops, IPPs, and the like, about 3,000 of those. And we've all invested over $1 trillion in this industry. So this is a big, big industry. And if you look at that, that means every one of us, or every customer, this industry is investing about $7,000 to really service this power that we get every day.
This is US only?
That's US only. So, yes.
So that's just the 7,000 per, that's the infrastructure, that's not like.
Not the fuel, not the ops, that's really the asset. Yeah. So, I mean, as I go to the last slide, when we talk about other countries, we have to keep that in mind to provide this level of reliability. It costs money. So if we look at this, then we have to ask ourselves, is this industry really delivering what it's supposed to deliver, right? What do we want from an industry like this commodity, right? We'd like it to be reliable, like it to be cheap, and we would like it to be clean and safe, of course, right? So if we look at how it's doing over the last, I took it like 10 years from EI, and if you plot the cost per kilowatt hour of the industry, it's rising. It's a bit higher than inflation rate, all of this. So it's tracking reasonably okay, although it's not, it's higher than inflation, let's put it this way. But it's tracking in something we can probably consider it to be okay. This is looking at it from all the investor-owned utilities in the United States.
You make those orange and blue on purpose?
Is there any other color? Now, if we look at the environmental footprint of the industry, remember, I mean, power systems, they really pollute. About 40% of the pollution on Earth is caused by power systems. So definitely it's one of the major polluters out there. And it used to pollute a lot more than today, especially when we were running coal plants, when we didn't have EPA regulations as strict as today. But now, if we look at the environmental footprint of the industry over the last 10 years, we see it declining. It's probably not where we want it to be, but it has a good trend, especially as more and more gas is coming in, more renewables are coming into the picture. But then if we look at reliability of the industry, that's really getting a major, we're getting a major headlines. Especially now as the weather is changing. We got a couple of hurricanes in the East Coast, Irene and then Sandy, where a lot of people were out of power. But that trend is not really just the last couple of years. We look at I looked up some of these charts, and this is number of outages that we're getting in the industry. So it's really on the rise. So we look at it overall. We see an industry that is essential to our being, to our productivity, to our way of life. It's delivering a cost slightly higher than inflation. We can probably live with that. Reliability is just not as good as we'd like it to be, although in many countries they dream of this reliability, right? And environmentally, we're doing okay, although we need as a country, because we are also, as US, we're contributing 25% of the global emissions. So we need to pay our fair share of looking at environmental footprint.
So is your data for your plots on the left, is that EIA data of all the states?
That's all the investor-owned utilities.
So IOUs, that's 75% of the electricity that we sell.
Yeah, it's now down to about.
And what about the CO2 emissions?
Same,
So only IOUs?
only IOUs.
LADWP pollutes a lot in Wyoming.
In Wyoming,
Yeah.
okay, doing what?
Yeah, and it's not counted here, okay? Just want to make you aware.
Sure. Yeah, there is no data that's 100% complete, but we have to look at it and assess for us. We have to assess where we are and where we're going, right? So, but then there is also the hidden cost of this industry, which is when we have a major outage, these outages cost industry money, right? It's not just that we had an outage. The hidden cost is somewhere between $10 and $80 billion a year, depending on how many outages we got, how widespread they are. If we look at where I live now in New Jersey with Hurricane Sandy, we had several days of people, millions of people without electricity. Actually, I was out of the country and I couldn't get back because all the airports on the East Coast were shut down. So I had to be stranded in Istanbul with my wife and kids here, and so she wasn't very appreciative of me traveling that day. So that's the industry we're in. Now, when I left Illinois, I have learned a lot from Professor Sauer and Professor Pai about stability. That's the area that I worked in. Lots of mathematical equations in my head. And that's really what I left with, a lot of good knowledge. I thought I knew a lot. And then I went to GE. And the first thing they did is they had, back in '87, there was a major outage on the West Coast. And they said, okay, here is all the data.
So only 3 weeks we had in Idaho, okay?
I'm sorry, what 3 weeks?
That's the one where the tree was touched by a line, and then it took out the Idaho power and light system, and then the West Coast lost something like 10 million customers. Or am I talking about the wrong one?
It's the one I'm talking about is the '87 one where the Intermountain Power Project was the major cause of the instability there. But at GE, when I left here, remember back in '87, there was no mobiles. Computers were scarce in a way. GE gave me a brand new VP100 bump terminal to work with. So that was the era, right? You don't have a lot of Googles and things to work with, programs on the internet to download. You had to figure out a lot of things. And at that time, analyzing and trying to take this knowledge and apply it to a real problem where LADWP was waiting for an answer by the day is definitely a trying experience. But I have to say the knowledge that I gained here really helped me a lot in figuring out how to reduce that model, how to come up with dynamic equivalents to be able to analyze it with the limited resources we had at the time. Now, after GE, as I was there was ABB was really making big headways in the US, capturing a lot of power plants from GE. And the key thing, they were innovating on the environmental footprint with the NOx reductions at the time. And that got me really attracted to go and work for ABB. So if we look at the gas turbine technology and the innovation that happened in gas turbines in terms of reducing the heat rate, and if you look at it, coal was the king back then, but then coal was cheaper, lower heat rate than gas. And that's why we're using a lot of coal. If you look at the installed base in the US, has a lot of coal. But then gas came up and really innovated quite a bit. And back in the 1970s, the era of, big is better, didn't make any sense anymore. That's when started to converge. Gas started to converge. Smaller size started to converge with big size. All right? Because previously the whole power system is built around centralized big power plants, right? Because those were cheaper. That's the best way to deal with it. And that's why we have the system the way it's structured today. But back in the 70s, late 70s, that story started to break up. And definitely in the 90s, gas became cheaper than coal. The heat rate, as you see, continued to innovate. And now we can get actually heat rates down to the 6,000 and 5,600. So about 60% efficiency on combined cycle. This had a tremendous impact on the power system and the makeup of the energy that we have in the US.
So what do you attribute the improvement to? Better insulation?
Better installation.
Insulation.
Within, it's a lot of innovation the guys did in tolerances within the gas turbines and the way they designed it. The combined cycle when it came up also, that helped a lot. Because now we can get with gas turbines about 40% efficiency, but then when you couple it with a heat recovery system, you come up to 60%. So that beats the socks off any coal plant today. And the other thing, it doesn't tie up a lot of capital. It's much smaller systems. You could design it as 100 megawatts, 80 megawatts, whatever you need it. Doesn't have the environmental footprint that coal has. And as we'll see in a minute, how the whole generation mix really changed. And the reason why I talk about this is stuff that happened in my lifetime. All right? This is since I left Illinois, and you're going to be leaving soon and moving on, and things will happen in your lifetime. And so it's good to see what happened and kind of learn from the trends that we see in the industry. The industry innovated also in the energy efficiency. When I graduated here, we didn't have compact fluorescent lights, right? We didn't have the same focus on the building, installations that we have today in terms of regulations. The equipment itself, whether it's a TV or anything, the power electronics was consuming more energy than today. So every little thing, the appliances didn't have the Energy Star that we enjoy today. So when people design things better, it works, gives you more, lasts longer, and consumes less. And the utilities have, through the regulator, because it's the cheapest kilowatt hour you could produce is the one you don't use. Right? That's the cheapest kilowatt hour you can have. And you see different states investing at different rates in energy efficiency today. So in my state of New Jersey, they are investing about $33 a year per capita in energy efficiency. Now, in Illinois, try to look at Illinois, they still have, you're probably very efficient already, $5 per capita in Illinois. So different states have different focus. Definitely the ones with the high cost of energy tend to spend more on energy efficiency because the bang for the buck is there. And that's paying off. If you look at how much energy we are not using today, this is cumulatively over the years, how over the same period, sorry about the x-axis, it's 2000 to 2012, and how you see the amount of energy that we're not using today. It actually lowers the energy and the heat, so it lowers both the CAPEX and the OPEX of the industry. Now, in my lifetime also, solar really innovated quite a bit. When I was here, I believe at that time, Maria was working a little bit on power electronics, and then Professor Auberty came over, and he was also working on power electronics. And I didn't know it. power electronics. I didn't really pay attention. I was in the big stuff. I was in the stability, right? But power electronics really matters, and the cell efficiency matters, and the whole industry of solar innovated quite a bit where they were able to drop the cost per watt from $12 all the way down to below $2 today installed. So if you're going to do your 1 megawatt here, you're not going to pay $12 per watt. You're going to be paying somewhere below $2 installed. That got us in a range where it is actually crossed the critical point of grid parity here. And the adoption of solar globally is growing quite a bit. And that also changed my career. I changed from the traditional grid to renewables about 4 years ago, as I saw this is becoming real, and it's no longer just a hobby stuff. And this will accelerate, not only in the US, not only in Europe, but we're going to see it mainly in countries that never had a grid before. This is a game changer. When you can now have a power plant so modular, you don't have to invest $1 billion to get the first electron. You don't have to build 1,000 megawatts to get the first electron. When you could just build it with one solar panel that probably costs you $300. This is a game changer for a lot of people. And today, this is another area that I'm working on with the company, which is really in the storage area. We're seeing storage also. If you read, Google, go to conferences, this is a very, very hot area these days, right? We had storage. We had home storage pipe, right? That's what we had. But this is a great thing. It's the cheapest, the best thing you can have. But unfortunately, we cannot have it everywhere. It's just nature does not afford us every place to have home storage pipe. Yes?
When you say battery cost, what types of batteries are you referring to? Is it a
All of
specific
them.
one?
I mean, you have, the lead acid is pretty much commodity today, so there isn't really much dropping in lead acid. But lead acid is kind of the most expensive battery you can have today on an LCOE basis, on a levelized cost of energy basis. But then lithium, flow batteries are the next thing now.
And they're all included in that?
They are all in here. So what we're seeing today is that on a kilowatt hour, the cost is dropping significantly year after year. And it will get in the zone soon, definitely before 2020, where it now enables us to store it and put it back in a cost-effective way. Now, if you couple this with renewables, that's another game changer in the industry. So this is very, very exciting area to look at. So we looked at different trends happening. Now, the industry we're in is not dead. It's definitely alive. It definitely feeds off these innovations. We are part of it. And if we look at it in a grand scale, in the US, if you look at how we changed the generation mix in the US, and you cannot change it in one day. You have a massive industry here. We said it's $1 trillion. You cannot just wake up one day, say, oh, gas is now great. Let me scrap everything and install gas. Or smart grid is there. Oh, great, smart grid. Let's scrap everything. Costs tremendous sums of money to do it. So it happens slowly. But over time, we're seeing that gas is taken over coal and will continue doing so, especially now that we have gas with shale gas, just tremendous amounts of gas. We're seeing renewables. We always had renewables with hydro, but we tapped all the hydro we can tap, right? There isn't really much more we can do with hydro. But now with solar and wind, actually more than half the new installed capacity in the US is renewables today on a megawatt basis. More than half is already renewables.
What you're showing here is energy.
This is energy, absolutely. And so what we're seeing is that the industry we're in is definitely alive, definitely feeds off innovations. You're going to be innovating, and the industry will learn from it and will adopt it. And now we're looking at the unknown, the convergence between transport and electric with the EV, right? This is another game changer as the load on electric utilities is going to grow quite a bit as EV adoption grows. And how are we going to integrate that under the same infrastructure? Do we need to do something about it? How can we do it? Nobody knows yet. Still, right now, it's all small stuff. But when you start thinking about large scale, actually, some of my friends on the West Coast, if two of his neighbors have EV cars, have electric vehicles, he's not allowed to get electric vehicle anymore because their feeder cannot take it. It's already there. So how do you deal with it? How do you say time shift? Who's going to come first? So this whole area, whether it's regulation, whether it's physical infrastructure, whether it's money, has to be dealt with. Another area of innovation that I witnessed and I really lived it is in the regulation. We think of regulation as an area for politicians, but it has a major impact on what we do. Now, long time ago, before my time, the whole area of fuels was dealt with in the U.S. in regulation. So
Natural gas.
Natural gas, yes. The whole idea of regulation is to allow the market forces to take hold, because nobody wants big utilities going and investing big money on your behalf, and you're going to pay for it for the next 40 years, right? The more you could put that risk on the market and let the market deal with it, whether it pays off or they have to write it off, is better for the consumers, the theory is, right? That's the capital market. So more and more, the regulations are pushing for open access, trading, market rules, rather than regulated rate of return. In the fuel industry, it happened. It happened at the commodity level, and it happened on the pipeline level. In the generation area, after the oil embargo of the 70s, it also happened where more cogens were allowed and utilities were forced to buy their excess generation. And then when utilities were allowed to own IPPs, all right, outside of their service territory. And we'll see what that did to the US. So every one of those will change the industry. Now, I lived through the transmission regulations. So I was happy working on fax devices, my form of smart grid back in the early 90s, work on fires to control series caps. And then back in 95, 96, FERC issues the mega NOBR, and they start talking about open access. And we started looking at it at ABB at the time, and I got intrigued when I learned that you can actually drive prices negative. Never thought you could do negative pricing, but turned out you can. And I got big time into this area. So that whole open access of how to allow people to trade and transfer energy across the grid really drove a lot of innovation in the industry. And trading between utilities and between power marketers kind of skyrocketed by 200% after that. But then there were some reliability concerns. Actually, when it came out, everybody thought open access, oh, we're going to lose electricity, right? Reliability is just not going to work. What do you mean you're going to have anybody transfer whatever? Only engineers know how to deal with it. It was a big debate in the industry that we lived through. But engineers are innovative, and they find ways of making things work. But that also evolved into forcing RTOs and regional planning levels. And regional planning definitely is key to allowing more and more renewables to come on the grid. So for me, I worked on systems and IT systems to enable some of these RTOs. And sorry for the quality of the chart, I was cutting and pasting. But if you look at California, that was the first RTO ISO that came out. Actually, when the RFP came out from Cal ISO, at that time it was PG&E and Southern Cal Edison that put it out. Nobody wanted to bid on that. It just looked so weird. You know, they sent it to all these SCADA vendors. We were a SCADA vendor at the time. And everybody looked at it and said, what the heck do you want me to do? It's like unknown rules. I don't know what to do with it. It's a massive system. Now, at that time, we kind of thought we knew a lot. So we got into it and we won the project to build the Cal ISO. Now, this is far beyond just a SCADA system, I'll tell you that. It's at least 20 times bigger than a SCADA system. It involved metering infrastructure, new market rules, it involved transparency, settlement, SCADA, all sorts of things. But it was well worth it to get involved in it. We've done after that New York, and other companies got also involved in ERCOT and others, like West ISO and the like. So this is, again, another game changer in the US. That it's not only the physical layer that's important. As you think about power systems, don't think just about wires and generators and motors. Think also about the information layer on top of it. Think about the money layer on top of it. Always follow the money. Money is important and it drives all investments. We talked about the regulations. Today, if you look at it, 20% of US capacity, 20% is IPPs. All right? So these IPPs were utilities sold off their generation. Others were building like Turbine. They were just, you know, it was the Wild West for a while. Everybody is becoming a developer. Every real estate guy became a developer for power plants. And today, solar is the same. I mean, you get a lot of people that are involved in solar, never had an engineering degree. So you learn to be curious, you learn to be humble, and you just continue learning. So let's talk about the smart grid, right? Lots of talks about the smart grid. Why not involve the smart grid? Why not just change everything? Now, I tried to look at where we are in terms of rate growth. If we look at, for example, in the US, GDP, real GDP is growing at 1.8%. That's our gross domestic product. That's the value of everything we do, right? Inflation is running about 2.5%, all right? Nobody likes to pay more than inflation every year, right? It's kind of, okay, yes?
Are those average rates over that period?
Yeah, that's the cumulative rate. If you take 10 years and do just cumulative one, you'll come up with that. But then if we look at our consumption.
That's per year, isn't it?
That's per year, yeah. That's per annum.
So it's the average.
It's per year, but it's, yeah. Now, if you look at our consumption of electricity in the US, although we have more households, we have more people in the US over this period, our consumption only grew by 0.6%. And go back to that chart we talked about energy efficiency, where the energy we did not consume, that accounts for a lot of this. So we only grew at 0.6%. And that's putting a lot of pressures also on utilities when they are investing, right? When things are rising, there is room to add, right? We know that this year we have to add 2% because load is growing. That is that much budget I have to play with. I can decide to do that with smart, not smart. It's a choice, right? But when you don't have a whole lot of room to play with, then you cannot do this. You're constrained in a way. Now, if we look at the IOUs, the investor-owned utility electricity prices, this is what you and I pay, that grew at 3.1%. So they got more than inflation, right? You guys get salary increases more than inflation these days?
The retired people.
So they got more than inflation, but not so far more. But if we look at their cost of doing business, we see that generation cost, which is really the fuel and the bar they buy, it grew about the same, about 3%. But if you look at the bar delivery, which is transmission, distribution, and customer care, those three buckets, although they grew quite a bit more. So the cost for them spending on operating the transmission grid, the distribution grid, and the customer care from meters and all of that grew a lot more than inflation. And so you have to ask, as we think about the smart grid and the price tags, I mean, every estimating that we need $400 billion price tag to move to a smart grid world. Where can we squeeze it, right? So as you think and try to come up with the new innovations on your own, as you're doing your research, always think about the money too. Because if I can't afford it, I'm not gonna buy it, right? Regardless of how cool it is.
A quick question, what was the population growth in that period, the average population growth?
I don't know.
Because the population is growing faster than the
It is
consumption rate.
faster than, but our consumption is only 0.6%. So we actually constrain, the US is actually running, the load growth is very anemic in the US, and that's what's really hurting utilities. Because if you look here at their income, after all of this is said and done, their income is only growing by 0.8%. So they are making growth for their incomes less than inflation.
Still have major states where our load is lower today than it was in 2008.
Absolutely, absolutely. So the population, I'm sure, has grown more than this.
Well, but so depending on where you stand, it's a good news story,
Yeah.
which means we're becoming more efficient.
We're becoming more efficient. Yes, absolutely.
There's no doubt about that, and that's why that's not necessarily to the utilities, and they want to get into that game.
Now, but some aspects of smart grid are getting really installed, right? This is a university invention, wasn't it? Wasn't Professor Fatty that started this, BMUs, right? And look at BMUs today. I mean, in like 5 years, we're seeing more and more dots on the map. So some things where they make sense, doesn't cost you a whole lot of money, has an impact, cost-benefit analysis is clear, right? So the softer side of the industry, IT, information, will probably have more bang for the buck, right? And will get implemented faster. If we look at smart meters, now, smart meters are also on the rise, and a lot of this was driven by stimulus money when the economy was down. The government really pumped a lot of money to help utilities buy smart meters. But you see on the residential level, back in 2010, we got about 15% of all residential customers on smart meters. We're seeing the same across all three segments, industrials and commercials. Now, smart meters enable us to do more. It's not really about just seeing information, right? And we'll talk about that in a second. Now, I'll have 3 more slides and I'll close with that. These are really new stuff, and I'd like you to pay attention to it because I think it will play in your career. Last year, Southern Cal Edison issued an RFP to buy local capacity. They had a nuclear power plant, San Onofre, they need to retire, sitting in a zone where they cannot build or they are not allowed to build too much in there. So there are some environmental constraints. And so they need to replace that. They need to replace the nuclear plant will get lost, new capacity will come. Now, typically utilities, when you talk capacity, capacity means reliability, right? Because it is what I build to meet my peak demand. So I don't mess with capacity. Now, they issued this and PUC, the Public Utility Commission in California, actually encouraged them to consider all options on the table. All options. Don't discriminate against any technology as long as it can be cost effective and give you the benefit. So it counts as capacity and it's cheaper. So pick the cheapest on the market. And this is what they came up with. They still came up with 73% power plants. But they also bought 27% non-power plants. This is quite significant, is that a utility will think of renewables, of demand response, of energy efficiency as something they can call on at their fingertips, and it counts as capacity. They can actually exercise it. They push a button and it happens. Now, this in the old days will never have happened because we didn't have communication systems that were cheap, fast, effective. Now we do, sensors. We didn't have what we have today. So whatever has happened over the last 20 years to enable more of this to count as capacity is crucial and will continue to increase. These were found to be more cost effective than building more of this. Because that was the criteria. So on equal footing, you have to evaluate everything. So we're going to see more and more that these types of exotic technologies, they are becoming component of the grid that we rely on to keep the lights on. Now, SCE did this with the requirement that they control the switches. So you do it as a developer, but give me the controls. I will push the controls to exercise this, to exercise that. Now, the next trend that's just happening right now is in New York. New York said California is great, but we're going to be even better. We're going to take it one step further. And we want a lot of this stuff, but I want it to also work under market forces, not just utility controlling everything. So I want it to work under market forces. That means now we're going to have all of these technologies, not rate-based, where a utility will buy it and put it in the rate on your account, but let the market invest in it, the market taking the risk, and the utility and the market need to work together in a transactional layer to issue right market signals, just like wholesale markets are doing today, but now happening at the retail level. A lot of innovation is required to make this work. The story is not known how it's going to play out. This is the story for the next few years. So we talked about innovations in the for people who are comfortable under the light and air conditioning. Now let's talk about the ultimate innovation. Now, did you realize 1.5 billion people, that's 1,500 million people, never seen electricity in their life?
20% of the world population.
Yeah, it's a huge, man. It's a shame actually, but it's a huge. And they will have no prospect ever of getting electricity if we wait for utilities to provide it. It's just, there isn't $7,000 per person to be spent. I mean, who has it? You know, this requires tons of money to make it work. Tons of money. And we talk and then you talk about fuel. That's even more. So now we go back to where Edison started. Edison started as a microgrid DC sitting in New York City selling to his, his block, right? Now, we're seeing a lot of innovation, putting some solar, some batteries, this and that, and providing it on, eco energy, eco power, small amounts, but that's all it takes to make a big difference in their life. It's what makes the difference between you seeing and not seeing at night, right? So we're seeing this is an area of a lot of innovation, a lot of it at the physical layer, and a lot of it also at the transactional layer, the business layer. And just leave you with that because this is one thing I didn't learn in school, that money counts. But it really does. Now, there's a good success in Africa and in Asia. The same people are already being served by the mobile telecom. Had they waited for the old landlines to come, they would never have come. But now, more and more adoption, millions of people, most of these people, probably half of them already have cell phones. All right? So the cell phone is there. There is no reason why we can't have electricity and innovation in that way. So as we go forward, and this is my last slide, I promise, we're seeing that economics and reliability, not just economics, are really driving us to think smaller. In the good old days, economics and reliability forced us to have a big centralized power system where you have big guy, generator, transmission, and little consumer. Now we're seeing consumer is probably going to be in the driver's seat. He's making energy decisions. He's part of the game. We're seeing more distributed infrastructure coming together. And that requires a lot of innovation. As we're putting solar out there, we see it. There are limits here, limits there, everywhere. And a lot of it is because we haven't, as an industry and as universities and as everybody, the whole ecosystem, innovated enough to enable all of this to happen. So areas of protection systems, I don't know. This is an area I've never really studied. I had my career so far very little in protection, but it's an extremely important area. Of how do we make protection systems that really adapt to all of this and make it happen. Because without safety, nothing will go forward. So this is an area of innovation. Efficiency of the solar panels, today it's somewhere around 19%, 18, 19 on the commercial stuff, 22. This can also take a major step up. Imagine if solar panels get up to 40 and 50%. What will do to the cost. Distributed and microgrid controls. I was very happy today to learn that there are thoughts to make this building microgrid. I mean, if I were sitting in your shoes, I'll be like on my professor's back every day to make this happen. This is a major area of innovation. Department of Defense is going to be spending billions of dollars in this area. So having this building and having, not to farm it out to a company to do it, but having you with the controls to really make this thing happen is definitely a game changer for your career. Storage, we talked about it, still in the early stages. Much more is going to happen in this area. Big data. We all hear about big data, big data, big data. And all of these systems out there, they have sensors, they have communication. We're going to collect, nanosecond information. Information is going to go everywhere. What to do about this? This is a big area. There are lots of startups in California looking at big data. It's important. And we have to stay curious. What I learned in my career is you cannot dismiss anything because things that look silly, okay, common stability, this and that, everything else looks silly. It's not silly. Over time, people perfect it and it becomes part of the mainstream. As we talk about distributed assets. Now you're going to get the same energy from thousands of assets, millions of assets. Now our SCADA systems that were designed, the largest ones were doing 60,000 points, 100,000 points. That's pushing the limits. Now what if I have now millions of points in real time? And I have to really transact and do stuff with them because it's money flowing on these wires. Retail energy trading and the big unknown, how to deal with electric vehicles, right? There's a lot of momentum in the favor of electric vehicles. It's far more efficient than the cars that I drive today. If you look at the engine efficiency of this, it's so much higher than the engine efficiency of your car. It's probably 4 times more efficient. So there's a lot riding and driving this to happen in addition to all the environmental stuff. And the technology of batteries, renewables, and the like is going to drive this even further. So this is some of the stuff that I dealt with in my career and some of the stuff that you will deal with in your career. And with that, I'll stop here.
Any questions for Hisham?
Could you go back a slide, please?
One.
Yes, just one. So when you're comparing how it was almost really beneficial for Africa to skip the landline and go to, that enabled them to use phone technology. Is it your opinion that right now is a time for the power grid to be in Africa, with the existing technology that we have?
There is no point in time where technology will get perfect enough for us to say now is the time, right? Even solar, when it was at $12, what you do is you find applications that value that at $12, and you go after this. Space industry valued that even at $100 to send satellites to space, right? Or else they're going to do it without the anybody. And you'll find applications. So you have to find places in the market. It's not talking about government subsidies and the like. You have to find viable places where you can really have applications addressed. Today, for example, take Africa. The powering of these cell towers, who do you think does it? They are paying diesel, right? Diesel, the most expensive form of energy, is powering these cell towers. Now there is more and more to put solar and batteries in there to aid the diesel. So it's like a hybrid system. Some people in India are innovating where now, I'll go after these towers, serve them their energy, and I'll serve the local community. Now that I got most of my money, can I guarantee? How else can I now serve the community and get the extras from them? There's a lot of innovation on the business layer here to make it happen. But I believe over time it will improve. But unless you get in it now, there will not be enough economies of scale to get these cost points to go down. Because that only can be driven by more and more volumes. When you get more volumes, more people, bigger ecosystem, and the numbers start becoming more manageable.
And I take it that's what you foresee for storage to happen.
Yes. Actually, for my career, I'm fighting with my wife, but this is the area where I'm now leaning towards. And we're just having big debates if I'm going to really commit to being on the ground or not to make some of this happen. But lots of people are pioneering in this area. We're seeing startups, we're seeing some venture capital coming into this space, both in Africa and in India. So it's just at the beginning stages of becoming real. For many, many years, decades now, donor money has been going. But a lot of that has been failures. No maintenance, no follow-up, and it just hasn't taken off. And it will never scale. Donations never scale. It has to have a real business sense behind it. When people make $2 a day, if they make $3, what do you think they spend the third dollar on? On this device today. They spend it on the mobile phone. That's what they are doing today. They are valuing the connectivity to the rest of the world and the information they are getting to be as equal as the food they eat. So today, people are paying for the phone, even though it costs them in percentage to their income quite a bit. But it's a valuable thing to them. Now, energy has to be brought to those places. I mean, when people have to spend all of their time bringing water, just go, the lady goes out, takes her daughter with her, and they go out 6 hours to bring water. I mean, come on, how productive is that household, right? When you have to do your farming, how much productivity do you get out of a farm when you don't have machines? You don't. I mean, you're not going to be competitive. We talk about globalized economy. When you have 20% of the population is not connected to the global economy, then they don't exist. They just don't exist. We have to find a solution. And where do these people end up eventually? They will end up on your shores. Because people are not just gonna open a grave and die. They are today, all the ships going to Italy today, right? We see it every day. Immigrants.
And some people even make it.
And that's true. Half of them die on the way. But people will do anything because they have to survive. They have to survive. So we have to address it for everybody's interest of the world.
All right, so that's your homework for.
Thank you guys, really enjoyed being there. Thank you. See, I think we're all here.